Hello, my name is Janet Herring. I'm the director of the Swiss Federal Institute of Aquatic Science and Technology, which is known by its German acronym ERWAG in Switzerland. We're located just outside the city of Zurich in Dubendorf, and we have a second site just outside the city of Luzern in Gestanenbaum. Altogether, about 450 people work here in all areas of aquatic science and technology, from water and wastewater treatment and fully engineered systems to aquatic ecology in remote mountain areas. I'm looking forward very much to appearing at the TED panel next week, and the subject of that panel is water and energy. And in Switzerland, we're very aware of the connection between water and energy because about 50% of the electricity production in the entire country is derived from hydropower. And this is a long history in Switzerland going back really to the mid-1920s or so. In Switzerland, there's a long tradition of fairly massive water infrastructure. Because it's an alpine country and subject to flooding. The first dams and flood control measures were conducted to reclaim water and to control floods. And after that, it also started to be developed more and more for hydropower. Until today, of course, hydropower is one of the major basis for infrastructure development in that sector. Hydropower is often thought of as a very green type of energy, as being CO2 neutral. And compared to many types of energy, it is very green. But there are also aspects of hydropower that need to be taken into consideration so that the hydropower operations can be done in a way that has minimal kind of impact on the environment. And there are two primary issues with hydropower that I'd like to mention just briefly. The first has to do with the residual water flows. So essentially, when you have a hydropower operation, if you're concerned only with energy, then you manage the release of water to time that based on when you need the energy. And that can cause a phenomenon that is known as hydropeaking, which is extremely hard on the environment downstream of the dam. There's also a problem that at some times there may be almost no water in what used to be a stream downstream of a dam operation. And so part of the management of hydropower operations and also the design of measures that might offset these problems are part of the concern and part of the area of activity for ERWAG. Another issue that has been well known for a long time in tropical regions is that when you create a reservoir, you tend to flood a large area. And often that area has a lot of vegetation in it, and that vegetation starts to decompose and decay underneath the water. And that decay process produces methane. And methane is a very strong greenhouse gas, a stronger greenhouse gas than carbon dioxide itself. What has been not so well recognized is that even in temperate regions, that same process can occur, and methane can also be generated from reservoirs in temperate areas like Switzerland. And that's something that has to be taken into account in the calculation of how CO2 neutral or how CO2 free is a hydropower operation in and of itself. And those are both aspects that we work on here at ERWAG. So I hope that I can bring this into the panel. I look forward to interacting with the other panelists and also with the community of the TED audience in worldwide. Thank you.